Alright, chemical bonding. Try to concentrate on what I say more than what's written up here. A lot of this is more difficult than I would like for it to be. So the main thing here is that electrons determine bonding. Oops. Let's do the right one. Electrons are important. They determine the bonding. Okay, and that's what I had you write. A Lewis dot structure, also called an electron dot diagram, is a shorthand way to represent valence electrons. It can also be used to show types of bonding. Okay, so I'm going to do an example. Lithium, you start with the symbol. You look up how many valence electrons it has, and it has 1. So I'm just going to put 1 dot to represent 1 valence electron. It does not mean that it has only 1 electron. It only has 1 outer electron, the valence electrons. Boron has 3, so I would put the symbol, and then I would put 2 on one side and 1 somewhere else. Remember that the most you can have is 8. Okay, so this just goes over what I said. It explains how to do it. What is a chemical bond? The definition of a chemical bond, it says the force that holds atoms together. That's good enough. Okay, and it's an interaction between electrons. Again, we're talking about the fact that electrons are responsible. It says that they are most stable, atoms are most stable if they have a filled outer level of electrons. And then it says, do not forget the octet rule. Remember, it can only hold 8, so it's always trying to reach 8. And then here it talks about how they gain and lose electrons. I want to skip that for a moment. Skip this, skip this. These are just electron dot structures. Okay, so ionic bonds. The electrons are transferred. They have high melting and boiling points. They conduct electricity. And then we went into some examples. Remember that alkali metals, like lithium, I'm going to use it again, only have 1 valence electron. So they can either get 7 electrons or give away 1 and become stable. Remember, they're going to do whichever one is easier, so they're going to give away 1. So lithium then becomes positive by 1 because it gave away 1 of the negative subparticles. Remember, I said an easy way to remember it. Giving is a positive trait, so if it gives, it becomes positively charged by the number that it gives. If it gives 2, it becomes positive by 2. If it gives 3, it becomes positive by 3. Alright, so let me put a blank page here. Okay, so alkaline metals, excuse my drawing, it's with a mouse. Alkaline earth metals, transition, we have boron, carbon, nitrogen, oxygen family, the halogens, and the noble gases. Okay, so oxidation numbers. This is the ions that they become. Remember, we said alkali metals all had 1 valence electron. I'm going to put valence electrons up here. 1 or 2. Oops. Sorry again, my writing is crazy. 3, 4, 5, 6, 7. Noble gases with 8, meaning they can't bond. They're already full. Okay, so these guys are going to give away 1 and become positive by 1. The alkaline earth metals are going to give away 2 and become positive by 2. I told you to add these to your periodic table. The boron family is going to give away 3 and it's going to be positive by 3. Because 4 is right in the middle, it can give away 4 or it can receive 4. So it can be positive or negative. This family that has 5, nitrogen family, has 5 valence electrons. It's going to get 3 electrons, and because it's taking, it's negative. 2 for the oxygen family because it needs 8. This halogen family has 7, so it only needs 1, so it's going to become negative by 1. And the noble gases already have 8. They don't need any more, so there's a 0. Now remember, this is a good way to tell if they can bond ionically or not. You would add the oxidation numbers. So let's take sodium, which is in this family, and chlorine, which is in this family. Now if I add them up, plus 1, plus, over here chlorine's is negative 1, negative 1. If it equals 0, then they can bond ionically. So we would say yes, they can have an ionic bond. Okay, so bring your periodic table that you have this labeled on. If you didn't label it, you probably want to pause right now and label your periodic table. These again are oxidation numbers. O-X-I-D-A-T-I-O-N. Okay, and the numbers up on the top are your valence electrons, but you should already have those labeled. Okay, so we're going to skip this, skip. We're also going to skip that. A lot of this we skipped over because it's redundant for one. Okay, so what do I want to put? Skip again. Okay, covalent bonds. Covalent, it's hard to see it up there, but covalent, co, means that you share. CO means to share. Think of a co-worker, you share the work. And valent is like your valence electrons, so they share valence electrons. So that's the important thing. Ionic transfers electrons, they give away or receive, and covalent shares electrons. Okay, so ionic, we forgot to say this, is metals with nonmetals. Covalent is nonmetals bonding with nonmetals. Alright, so if it's a nonmetal bonding with a nonmetal, it's automatically covalent. If it's nonmetal and a metal, it's ionic. Okay, so this repeats the same thing. Repeats. Diatomic elements are elements that exist as molecules with just two of them together. Remember the saying Hunkelbrief? These are the only elements that do this. Okay, so it would be elements that are naturally molecules with just two atoms each. Okay, a polyatomic ion means that it has gone through more than one type of bond. Poly means more than one. Okay, metallic bonds exist when a metal bonds with a metal. Okay, very strong. In this scenario, the electrons are mobile, which means they can move from energy level to energy level. They jump back and forth. So the electrons in metallic bonds, one more time, I'm writing it here, are mobile. Okay, that's the scientific word that they're going to use, meaning they can move around. They can go from one energy level to the next. So it says formed between atoms of metallic elements, the electron cloud around the atoms can move freely. So we've already talked about that. We can skip that. So one more time. Ionic, again I'm trying to write with a mouse here, is a nonmetal bonding with a metal, and they transfer electrons. This looks horrible. Okay, covalent, I'm just going to put COVAL for short, is when it is a nonmetal and a nonmetal. And they share electrons. Metallic bonds are when a metal bonds with a metal, and these electrons are mobile. Meaning they can jump from level to level inside the atoms. Okay, so that's your short lesson on bonding. Don't forget that your project could account for half of this standard. And if you still are not getting this, come on in the morning and I will help you.